Okay, so from here I'll break it apart. This is 0 automatically. 1 times this will still give us that. So I'm going to spread this. This will be partial square, partial over partial u into partial f over partial x. Remember, u times x, partial u times partial x is the same thing as partial x times partial u. I've illustrated it here. 2 times 3 is the same thing as 3 times 2. So this will become, remember, partial f, partial x, we've gotten it from this first one to be fu. Is equal to fu. At the end of the day, this one gave us fu. So this and fu is the same thing. So I'm going to do that substitution. So this should be partial over partial u multiplying. Remember, fu is the same thing as partial f over partial u. And also, look at fx, partial f, partial x is the same as partial f, partial u. So this can be written as partial square f over partial u squared. And also, if partial square f over partial x squared is fxx, partial square f over partial u squared should be what? fuu. And also, so we started from here, fxx is equals to, and it gave us fuu. So we agreed that we've gotten fxx to be fuu, and we've gotten fx to be fu. We have arrived at the whole of the left hand side. We have arrived at fuu. Now we are going to go to the right hand side. I'm going to clean the board. Now we recall that our partial u, partial t was what? Differential with respect to t. What did we get? K. Yes, that's what we got. Now let's come to the right hand side. We are going to find a way to evaluate this right hand, see if it's the same as the left hand side. We'll start with ftt. Now I told you that before you do that, you must first find the first derivative, ft. Ft is partial f, partial t. We are virtually following the same procedure. So by chain rule, this will be partial f, partial u, multiplying partial u, partial t, just like we did in the other case. The only difference is we will be using t here, whereas the other case we are using x. So this will be partial u, partial t is k, not so. So this will be k f u. Because partial u, partial f, partial u is fu. So ft will give us k f u. Now let's come to the second derivative. ftt is equals to partial square f over partial t square. That is what it means. Now this is the same thing as partial over partial t of partial f over partial t. Yes, I've still explained this. You can always spread second derivative in this form. Now this, how did I do it the other time? Maybe forgetting it. What did I say? Oh, I forgot to know. Okay. Yes, I'm going to apply a product rule. Yes, like the other one I did. I'm going to apply product rule. Now, product rule says, before I do that, remember partial f, partial t can be written in this form. This is partial f, partial t can be written in this form. Partial f over partial u multiplying partial u over partial t. So this can be written as, remember this is product of two functions, so we are going to apply product rule just like the other case. So keep this one constant, differentiate this one, plus keep this one constant, differentiate this one. So we keep this one constant, partial f, partial u, and differentiate this one. When we differentiate the first derivative to give us the second derivative with respect to t. Then plus, we keep this one constant, partial u, partial t. When we differentiate this one, now we get the second derivative, partial square f over partial u. Remember we are differentiating with respect to t, become partial t. Also, yes, now remember we are differentiating this with respect to t, so it will be partial square f, partial u, partial t. We are differentiating this with respect to t, so it will be partial square u, partial t square, like in this case. So, like similarly, partial square u, partial t square will be 0. So 0 times this will be 0. Why? See, the first derivative is k. K is a constant. If you differentiate it again, you will get 0. So second derivative, which is this, will be 0. Plus partial u, partial t is k. This one is k. And then this one, like we did in the other time, we're going to spread it. Partial over partial u into partial f over partial t. Also, so this will be equal to, this is 0, so we have k. Now partial f over partial t, I think we can get it somewhere. Look at it here. Partial f over partial t is kfu. Is kfu. So this becomes kfu. Okay, there's a partial here. Partial over partial u. Yes. K partial over partial u. This partial f over partial t. Partial f partial t is kfu. So this becomes k. Remember, this k is a constant, so it comes out as k squared. Now, so you are left with partial over partial u into fu. You know what fu mean? Fu is partial f partial u. Yes, we know that. I've explained it. So this will be k squared. Now, now look at this, is partial square f. Not so. Partial square f over partial u square. And this will be k square. What do you understand by partial square f, partial u square? In the other form is f, the dependent variable, u square is u. I believe we know that. So ftt is k square fu, because from here, this is where we started. We proceeded till we got k square fuu. Good. I'm going to use this part. Now, remember we are working on the right hand side, so we have gotten ftt to be k square fuu. Now we are going to multiply. We are looking for a way to get this. Now I'm going to write this ftt because to what we have gotten is k square fuu. But we need 1 over k square to be attached to ftt so that we get the right hand side. So we are going to multiply this side by 1 over k square. So 1 over k square ftt. We also multiply whatever I do on this side, I must do on this side too. So it will be 1 over k square, that is k square over k square fuu. So 1 over k square ftt is equals to fuu, because this will cancel. So you see that the whole of the right hand side is fuu. This is right hand side. And we've got fxx from the left hand side. From the other part I cleaned. Fxx was fuu, I believe so. Left hand side. So we have seen that the left hand side is equals to the right hand side. Simple, we have proved it. The left hand side and the right hand side are the same. I'll prove it, very simple. If you have questions, you can ask me. Thank you very much. That will be this exam, more to come.